Hello everybody, welcome back. Last time I gave you some of the rules of logarithm, I defined logarithm. I think I want to spend one or two lessons because it's going to come back to you every now and then when you do differentiation, when we do integration. So I'd like to spend some more time doing various types of questions so that you get used to logarithms. So we are still in topic 3. We are still in algebra and we're doing questions on logarithms. For your convenience and mine, I will list the laws we have. Log of AB to base x equal to log A to base x plus log B to base x. I'm going to leave a gap there because, not necessary. We'll see. Log of A over B to base x equal to log A to base x minus log B to base x. Then log of x power n to base A. I think let's keep to base x. So log of A power n to base x equal to n logarithm of A to base x. And then log of A to base A is 1. Log of 1 to any base, any positive integer base is 0. And we did the change of base. Log of A to base B is log of A to base x over log of B to base x. I will add 2 more as we go on today, not exactly definitions, but information. So let me take some examples. I made up this example yesterday, right, sitting at home. For example, you're told simplify. The idea of these questions is to make you get used to logarithms, that's all. 2 log x to base A minus half log y to base A plus 3. Very interesting. The problem I have here now is somehow students think you can do anything you want with logs. You remember I told you maths is not your grandfather's property. But majority of the students think, especially when it comes to logs, they can do anything they want because it happens to be in their family assets. So, and they expect everyone else to accept it. Unfortunately, we don't. For example, I have come across this. Log of A plus B to base x equal to log A to base x times log B to base x. In other words, if it is multiplication, you can split as addition. But if you have log of a single A plus B, you cannot split it as times. It's a one-way traffic, no entry. So you can't, when you say A plus B or A minus B, or sometimes also come as log of A over x over log B to base x. No, that doesn't work. It works only one way. So this is one common error. And the other one is 2 log x to base A minus half log y to base A. They will just say 2 may not be in this question. When I come across that, I will show you. So therefore, you have to be careful. Whenever you want to combine the logs, remember, there are no numbers here. So you can only combine logs if you don't have a number before them. This, I think I would put it this way. It works that way and works that way. It works that way and works that way. This works that way and works that way. This works that way, that way. This works that way, that way. This works that way, that way. They're all two-way traffic, but you can't say log of A plus B to base x is log A B, log of A plus B to base x is log A B to base x, or log A times log B. These are new modern formulae which I always say a funny thing to my students whenever they write this. to point out in a polite way that they are wrong and they remember, it might help you. The World Mathematical Society is supposed to be in Paris. I don't know whether it's in Paris or not. I always tell my students the World Mathematical Society is in Paris. Take this new formula, fly to Paris tomorrow morning. As soon as they open the doors of the office, present this new formula. If the World Mathematical Society accepts your formula, come back. From the day you come, I'll teach those new formula. Till then, I'm not going to teach them because to me, I haven't learned them. Meaning, you have to be careful. You can't just, especially when it comes to logs, stick to the rules. Don't try to create your own rules. Okay. So as I told you, you should not have this number. So look, if you have a power n, I can write n log. So if you have n log, I can write as a power n. So I'll write this as log of x squared to base a minus half. In fact, simplify as a single logarithm. Especially, you know why you need this? Because later on when you do integration, you sometimes they say express in the form a ln b or express in the form ln f of x. So you should know how to simplify logarithms. This half I don't want. So I'll write as log of y power half to base a. Remember, if this is base a, that is base b, you cannot combine them. The bases must be the same. So now 3, do you agree? Can I write as 3 times 1? Log a to base a is 1. So can I write it as 3 log a to base a, which is the same as log of a cube to base a. Why am I doing that? If I want a single logarithm, I should have only log, log, log. I can't have log, log and a number and try to simplify. So therefore, this is log to base a. Whenever you add, you multiply. Whenever you subtract, you divide. I am now coming from right to left. So log x squared plus log a cube is log of x squared a cube. Log of x squared a cube minus log will be over y power half. I have got now a single logarithm. Do you understand that? That's how you apply them. You cannot apply log laws. Apply the laws, these two, unless you don't have any number other than 1 here. Otherwise, you can't. So if you have a number, take it as a power. Let me take another example. Now I'm just going to do quickly because log of 1 plus x, log 1 plus a to base 10 plus log 1 minus a to base 10 minus 2. Now it is base 10. These two can be combined, but I don't have a log. 2, always remember in the previous case the base was a, so I used a cube. Here the base is 10, so it is 2 times 1, which is 2 log 10 to base 10, which is log 100 to base 10 squared to base 10, which is log 100 to base 10. So I'll write this as log of 1 plus a to base 10 plus log of 1 minus a to base 10 minus log of 100 to base 10. Now I can write a single log to base 10. These two are being added, so I can multiply the expressions. That is subtracted, so I can divide by the expression. 1 plus a times 1 minus a over 100, or log of 1 minus a squared over 100. Remember, I haven't written the base 10. Yesterday I told you, if you write log and don't mention a base, generally it is accepted as base 10. Or let's be precise and put base 10. Nothing wrong. Perfect. Then let's look at an equation, how to solve an equation. For example, let's say you've been given 5 power x equal to 3.26. Five squared equal to, you could take the square root, but you don't know xth root. You do know x. So, and if you put x as 1, 5 can never be 3.26, right? So it's some power of x. So the best thing we do is log, always take log to base 10. Log to base 10, 5 power x equal to log to base 10 of 3.26. Take x down. So x log 5 to base 10 equal to log of 3.26 to base 10. I'll show you another method. So x equal to log of 3.26 to base 10 over log 5 to base 10, which you can use a calculator and find out. Shouldn't be a problem. But however, there's an easier way. This is the power, that is the base, that is the answer. So use the definition of logarithm. Let me write here. If a power x equal to b, no, x power a equal to b, then logarithm of b to base x equals a. 5 power x equal to 3.26. So logarithm of 3.26 to base 5 equals x. Change of base, log a to base b is log a to base x over log b to base x. Or these days your calculators, you can do it directly. But if you can't, no problem. So I can write this as log of 3.26 to base 10 over log of 5 to base 10 equals x. That's exactly what I got here. So either you can do it that way or you can solve it this way. Good? Let's look at some other example. Of course, as I told you, you don't have to copy all this. You'll get a handout with these examples and the definitions. Alright? 2 over 3 log x cube to base 10 minus half log x squared to base 10 minus 3 log x to base 10 equals 4. You have to solve for x. I've just made up this question just to familiarize you with the log. Thank God everywhere there is a log except for 4. If you don't have to put a log there. You can if you want to, but no need. Wherever you have logs, simplify those. Remember I told you the number before must be 1 to use the first two formulas. So I'll write this as log of x cube power 2/3 to base 10 minus log of x squared power half to base 10 minus log of x cube to base 10 equal to, of course, I could have indirectly, these two are similar. So what will this become? Log of x squared to base 10 minus log of x to base 10 minus log of x cube to base 10 equals 4. 1 positive, 2 negative. The negatives will be in the bottom, the positive will be in the top in a log. So therefore, it's log to base 10 of x squared over, is not x minus, x times x cube equal to 4. That is log of 1 over x squared to base 10 equals 4. There are so many ways of doing this. So, what the easiest way of doing it? Okay, log of 1 over, therefore 1 over x squared equals 10 power 4. Remember, I can go back here. If log b to base x is a, then b equals x power a. So log 1 over x squared to base 10 is 4. So 1 over x squared equals 10 power 4. So 1 over x squared equals 1 followed by 4 zeros. Or x squared equal to 0.12. 1 over 100 is 001. Sorry, 01. 1 over 1000 is 001. 1 over 10,000 is 3 zeros and 1. So therefore, x equal to square root of 0.123 zeros and 1. It is plus 0.01. Remember, we got a log x. If x is negative, I purposely didn't mention it yesterday. This is most important rule because students think it works. Log of negative number not defined. Remember yesterday when I showed you the graph of log was like this. So there is no graph for negative x. Like, a power x can never be negative. There is no value of x. If a is positive, a power x is negative. So therefore, same way, there is no value of x. If x is negative, there is no logarithm. Log x can be negative, but x cannot be negative. So, even though, remember, I know, this is where we math teachers contradict ourselves. On one side, whenever you take a square root, please write plus and minus. And suddenly I'm saying, don't write plus and minus, write only plus. You might be wondering, why can't you make up your mind? Unfortunately, the function, remember, everything depends upon the domain. The function log x is defined only for positive domain, so it has to be positive. Is that clear? Good. I just want to take one quadratic equation and stop at that before I do another lesson where I want to go into the nitty-gritty of graphs and functions and so on. And I want you to introduce you to some of your A2 work. 5 power 2 plus 2x minus 28 times 5 power x. Examiners love questions like this. Rare, but comes. First and foremost, there is no log. Please don't say log. Oh, this is where I told you what the students, I've seen an answer like this. 5 power 2 plus 2x minus 28 times 5 power x is equal to minus 3. So take log on both sides, log of minus 3. They end up getting, okay, some of them, if this is minus, let's say, that's a plus 3. So they were justified. And then they go to say log of 5 power 2 plus 2x minus log of 28 times 5 power x. I'm sorry, log of a minus b is not log a minus log b. It's again Paris. You remember I told you Paris. Take it to Paris, get it approved by the World Mathematical Society, come back, I will teach this way. Till then, let me stick to the way I know it. So the question was minus 3. Was plus 3, wasn't it? Yeah. So the first job will be, do you recognize a quadratic there? First and foremost, x power m plus n is x power m times x power n. So split it as 5 power 2 times 5 power 2x minus 28 times 5 power x plus 3 equals 0. When you square 5 power x, what is 5 power x times 5 power x is 5 power x the whole squared, which is 5 power 2x equal to 5 power x the whole squared. So it is 5 power x whole squared, 5 power x and something like p squared, p and number. Quadratic equation. So you say let 5 power x be equal to y. That gives me 25y squared minus 28y plus 3 equals 0. Now I have reduced an exponential equation to a quadratic equation. Now we are in familiar grounds. You know, something like we used to have those steam trains. The steam trains, especially when I was young, it used to come from Mysore to Bangalore, from a place called Kengeri, which is about 2,000 feet, to Bangalore, which is about 3,500 feet. It would struggle climbing up. So that was what it was, the train climbing up. But as it climbed up and came to a plateau, it would accelerate. So now this was the express train. It was struggling, but from that place which is 2,500 feet, now once we have reached, we can gallop here. So remember I told you must show your working. 25y and y minus 1 minus 3 equals 0. Look, 25y squared minus 25 minus 3 is minus 28, and then minus 3 minus 1 is plus 3. So therefore, y equal to 3 over 25, y equal to 1. Fine. So 5 power x equal to 3 over 25. So x is equal to log of 3 over 25 to base 5. Very interesting. Which is, or then you can, as I told you in the previous case, write log of 3 over 25 to base 10 divided by log 5 to base 10. And then this one, y equal to 1, 5 power x equal to 1, 5 power 0 is 1, so x equals 0. That's fine, I'm not taking log 0. Log 0 is again not defined. Log negative is not defined. So log of 3 over 25 to base 5, you can leave it there as a log of 3 over 25 to base 10 divided by log 5 to base 10, or you can take x log 5 and then do it. Either way, or you can say x log 5 to base 10 equal to log of 3 over 25 to base 10, giving you x equal to log of 3 over 25 to base 10 over log 5 to base 10. And I can bet x is going to be a negative answer in this case, because 3 over 25 is less than 1. Remember yesterday's graph, the log value will be less than 1. 5 is more than 1, the log value will be, less than 0, more than 0. So negative divided by positive, check the answer, it will be a negative answer. Right? Thank you very much. What I'll do will be in the next lesson, I will go further. I will leave those rules there for the next lesson as well. I'll go further to talk a bit more of general theory and stuff and things like that. Okay? Thank you. Have a nice day. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.